It turns out that there are three major factors that can have an influence over the entropy or the disorder of a system. Remember that entropy is often associated with disorder, and what that means is how dispersed the energy of the system can be. The more dispersed, the more disorder, and thus the more entropy. The symbol for entropy is often S. So when you see S, that means entropy. Number one is that the entropy of a system increases as the temperature increases. Remember that temperature is a measurement of kinetic energy, or in other words, how fast particles are moving around. And if particles are moving faster because the temperature is increased, this is going to cause all the different particles to move about very quickly and increase the entropy of the system. Another factor that influences entropy is going to be the volume. Entropy tends to increase as the volume of the system increases. You can think of this as molecules spreading out. So as the molecules move faster, they can spread out further and further, and this is going to cause the energy to be more dispersed. Thus, the entropy is going to increase. And the final factor is going to be the number of particles in the system. The more particles that there are, the higher the entropy. This is because more particles are going to be colliding with one another, and overall this is going to cause more disorder for the system. In the first example, you have ammonia gas, or NH3, plus HCl gas, or hydrogen chloride, reacts to combine to make a solid ammonium chloride, or NH4Cl. Now notice that these particles are different in their physical state. On the reactant side, we have two gases, and on the product side, you have a solid. Importantly, remember that when gas particles are contained in a container, they are constantly moving around. These gas particles are bouncing off the walls and constantly moving around due to the kinetic molecular motion involved in gaseous particles. One of the properties of a gas is that they take the shape and volume of the container that they're in because they're not fixed to a single location. Remember, alternatively, that a solid doesn't move. It has a fixed and rigid shape. So because of that, it's going to take up far less volume or space. So when we think about the different factors that influence entropy increases, one of them is going to be temperature. There is no temperature difference here, so we don't need to really consider that option. However, as we'll notice, volume is one of the factors that influences entropy. And since the volume is going to be decreasing, that could be a tip-off that the overall entropy of the system as it moves from reactants to products is going to be decreasing. Similarly, we can look at the third factor, which says that if you increase the number of particles, you increase the entropy. And on the reactant side, we have two particles, two gaseous particles. And on the product side, you have a single or one type of particle. This means that actually the number of particles is decreasing, and thus we would expect the overall entropy of the system to decrease. In the next example, you have a molecule that is a solid on the reactant side and aqueous on the product side. This tells us that this solid has been dissolved in water. Remember, that's what aqueous means, dissolved in water. Now think about the physical state of a solid. A physical state of the solid is going to be fixed and rigid. It's going to have a fixed and rigid shape and volume. It's not going to change because that is the definition of a solid. However, consider a solution of these same particles, but instead they have been dissolved in water. So now you have water in your beaker, for example. You added water to your solid mixture and you created an aqueous solution. What this means is that we still have the same molecule and nothing about it has changed. It's just dissolved in water. And what this means is that it's now in a liquid solution. And therefore, the particles are going to be far more dispersed. And remember that entropy is a measure of the dispersion of energy. We often say that more disorder. But what it really means is that the energy of the system is more dispersed. And since the particles have now become more dispersed, they're now beginning to flow and move freely through this solution, we are increasing the entropy as we go from a solid to this aqueous solution.